Ladies and gentlemen, welcome to Kristiina's Tech Talk on GraphQL. Kristiina, please take it away.
Okay. Can you see my desktop? Yep. Cool.
Yep.
All right, wonderful. My name's Kristiina, and today we're going to talk about GraphQL. This Tech Talk is sponsored by Codesmith and Single Sprout. So quick overview, we're going to cover what is GraphQL and some of its origins, some problems that it solves, and some tools that you can use to use it in future projects. According to co-creator Dan Schaefer, GraphQL is a query language for your API that shifts the contract between clients and servers, that allows the server to say, these are the capabilities I expose, and allows the client to describe their requirements in a way that ultimately empowers product developers to build the products they want to create. Ask for exactly what you want, and you get back nothing more and nothing less. GraphQL is declarative and specific. So a little bit about GraphQL. It was developed in 2012 by Facebook employees Nick Schrock, Dan Schaefer, and Lee Byron, and released widely as open source in 2015. And what's really cool is that it's used by a lot of really big companies like SpaceX, GitHub, New York Times, Airbnb, and Facebook, of course. Why did Facebook create GraphQL? So they had a problem. Their existing mobile app was slow and prone to crashing due to the billions of REST HTTP requests happening as their app scaled. They needed to create a new version of their newsfeed on mobile that would fetch the information they wanted in a more pinpointed and less bulky way. So they developed GraphQL, which solved the problems of overfetching data and maintaining the speed and performance of their app. A little high-level overview of what GraphQL is. It's a type system defined within a schema that describes how and what data you can query, an abstraction layer that allows you to query your data in a really specific way. So it's not a database itself, but a tool to query your database. And it can be used with any backend framework or programming language. So let's start with talking about schemas and types. Schemas are similar to a schema in SQL or a model in MongoDB. It defines a collection of types and their interrelationships and how they're connected. It's where you define what you want to query and what you can expect to get back from your service. It's made up mainly of object types, and these are defined within your schema and contain fields that describe what you can query about each type. And within your object types, you have fields, and these are like attributes. They define the different characteristics of each kind of parent type that you can search for. So for example, let's say you have an object type called character, and in that character type, you have some fields like an ID, a name, the role, like what it does, and then scalar types are types that you assign to your fields. So basically GraphQL is types on types on types, so many types. Scalar types are primitive types that we assign to our fields, which determine what data type the fields need to be. So for example, a name needs to be a string, and so on and so forth. Let's delve into object types and what they do in our schema. So this is an example of two object types in a schema. The first is an author type. So we're in our schema, we're declaring this instance of this object type called author. On author, we can query for the following fields: an ID, name, age, and books that this author has written. And then on line 47 of the top example, you'll see that we've defined the relationship author has to another object type defined below, the book type. And it has a resolver function that describes the action that you want to perform and the data you want returned if you're including this other type, like in a query for author. And in this case, it would be to return books that correspond to this author's ID. The book and author types are linked together. And you can see in the bottom example for book type that on line 63, we have linked book type to our author type in the same way. Ooh. Root queries. Okay, so every schema also includes a root query. A root query is a high-level bird's eye view of our schema. It's a collection of our object types that we defined earlier, but all in one place, and it designates the jumping in point to our graph to query data. For example, when someone queries a book, which you'll see on line 76, the root query instructs GraphQL to use the object type of book to go and get it. If someone were to query a specific author, GraphQL would use the ID to go and get it. And yeah. Queries and mutation types. So queries and mutations are also considered types in GraphQL. What is a query? A query is a string that is sent to a server to be interpreted and fulfilled, and it then returns a JSON object back to the client. It's a read operation, so we're fetching for information. A mutation is an example of a write operation. It's used when you want to update or add data to your database. In this example, so in the query example, we're querying authors by name, and we want to return a list of books that they wrote, including the name and the genre. On the right, you can see that the shape of the response, it's structured in exactly the same way as the query. So it's very easy and digestible and very easy to just take in and follow. And we're getting exactly back what we had asked for, nothing more, nothing less. On the right-hand side, you'll see our mutation, where we're trying to add an author. In this case, Johnny author, age 25, and then the ID would be dynamically generated. And as you can see to the right of that example, in the pink there, we have queried our authors again, and it shows that Johnny author was in fact added to our database. So GraphQL, I like to call it the problem solver. Here are some of the ways that GraphQL solved Facebook's problems. So for Facebook, and now for everyone else who gets to use GraphQL, it's awesome technology. It has solved the problem of overfetching and underfetching of data. And that's a problem that's common in REST. It allows us to request and receive back only the data that we need. It reduces the overall traffic between the front end and back end, and gives us greater control over the shape of the data that we receive in our responses. And this leads to better user experiences and a better improved developer experience as well. How REST APIs give us the runaround. So here's an example of a REST HTTP request and response. Let's start with this example. So we're making a GET request to an API for user one. We're hoping to get their name, username, and email address, let's say. But the response we get back is a JSON object that includes way more information than we actually need. We get all of their personal details, even down to their geographical coordinates. Now we also need to sift through all this extra data to find what we're looking for. Time is ticking and network resources are wasted. This is data overfetching. Baby, we've got nothing but time. So here, let's say we also want to get the same user's posts and comments on their posts. We must make 2 separate requests to 2 different endpoints. This is very inefficient. As this application scales, this means millions of extra requests every day, which means slower response times, a slower running app, precious network resources being used up, and it also shows how data overfetching and underfetching are linked. The catch-22. We're underfetching data because we're unable to get all the information we require in one API call, and then we're overfetching data because we have to make multiple requests to multiple endpoints just to get the basic information that we need. Wouldn't it be nice if we could ask for exactly the data that we need and do it all in one call? GraphQL makes this possible. No more over and under fetching. Here in this example, we are requesting for the same information as in the previous REST HTTP request example, but we're using GraphQL. We are able to request for user one's ID, username, name, and email. And what is returned is just that and nothing more. Overfetching and underfetching data is no longer an issue. One endpoint, one call to rule them all. So this example, so on the left, we have our query, and then on the right, we have the response. So this example highlights the flexibility, precision, and efficiency that GraphQL brings. This query is requesting user one's ID, username, name, and email, their posts by ID and title, comments on their posts, and all of the commenters' information. GraphQL allows the client to be a lot more specific about the data it's requesting. And we're getting to request all of this data in just one call to a single endpoint. This is peak declarative data fetching convenience. Now, what are some popular tools? These are the most popular GraphQL server and client tools. Apollo is probably the most popular out of all of these. So they have lots of cool products that you can use to make GraphQL really fun. Apollo being the most popular, I would say definitely, let this be a springboard and pique your interest to research more. And finally, so in our production project, we are using GraphQL, and we're exploring how it's going to help us handle errors in our production project. And it's showing us so much about the tool that we're building, and we're really excited about it. And that is my talk. Thank you.
All right, let's everybody unmute. Give Kristiina a huge round of applause.
Yay, Kristiina, yay!
That was so good.
First tech talk of the cohort.
Very good.
Woo! Thank you.
Before we let you all go, does anyone have any questions for Kristiina? I actually do, Kristiina. You're in one of your last slides, you mentioned that you are using GraphQL for your production project in an error handling capacity. Could you say more about that?
Yeah, so if a query that you are doing in GraphQL, if it has an error, you will get that back in the response, but it's not always very digestible or human readable, and often quite vague to get to like the root of what went wrong in your queries. So one of the features that we want to implement is to work on translating those errors into a more kind of human readable language and a little more precise, so that it will really help you to improve your querying.
Super helpful. Thank you.